Hello everyone, welcome to this video. In this video we'll be looking at another question from function of 2 or 3 real variables which appeared in the IIT-JAM 2020 mathematical statistics paper. This is a multiple select question, more than one answer could also be correct, and it is a 2-mark question. So here in this question they are saying the arc length of the parabola, this parabola is given to us, y square is equal to 2x, right? So they are asking what is the arc length, and it is given by which among these 4 options, right? And the arc length, it is measured between the points of intersection of the parabola y square is equal to 2x and the straight line y is equal to 2x. So let's, in order to understand this question, let's first of all have a graphical look for this question, right? For the solution we are given a parabola whose equation is known to us as y square is equal to 2x, and we are given some a straight line which is y is equal to 2x. So these two things are given to us, right? So let's see what are the points of intersection of these. So what are the points of intersection? Let's call this as equation 1 and let's call this as equation 2. So points of intersection of equation 1 and 2. So we have to see this thing. So here for the points of intersection we could substitute the value of x from both the equations and equate it. So you see 2x is equal to y square here and 2x is equal to y square. So that means both y square and y has to be equal, or you could write this to be y square minus y, that is equal to 0, or you could take y common, so it could be y minus 1 is equal to 0, right? Now the multiplication of two things is equal to 0. That means either the first thing is 0 or the second thing is equal to 0. So that means either you have y is equal to 0 or you have y is equal to 1. So you obtain these 2 points, y is equal to 0 and y is equal to 1. If you have y is equal to 0, then what is the value of x? Then you have y is equal to 2x. You can substitute y is equal to 0 here, so that you have x as also equal to 0. So in this case the point of intersection is the point here that you obtained is the value of x is 0 and the value of y is also 0. In this case when you have y is equal to 1, you could substitute it in y is equal to 2x. So in place of y we have to substitute 1, so you have 1 is equal to 2x, so that means x is equal to 1 by 2. So that gives you the value of x as equal to 1 by 2 with the value of y as equal to 1, so that your point become 1 by 2 comma 1. So these are the points of intersection. Now what we are required to do is we are to draw what is the length of the curve that we are to find for this particular question, right? So let's draw the coordinate axis. So this is your y-axis, right? And similarly this is your x-axis, right? So here this is the origin. So let me mark few points. Say it is 1, it is 2, it is 3 and so on. This point is 1, this point is 2 and so on, right? Similarly here this is -1, this point would be -2, this point is -1 and so on. Now we wanted to plot these 2 points. So we wanted to firstly plot the straight line y is equal to 2x. So let's plot y is equal to 2x. So you see one point is 0 comma 0. When you substitute x is equal to 1, the value of y is 2, so the next point would be somewhere here. Next when you substitute 2, your next point would be somewhere here, right? So you have something of a straight line like this, passing through origin and going in this direction. So we have some straight line like this, right? So this is your y is equal to 2x. It would be moving here in this direction, and similarly you could extend it further in the negative direction as well, right? So this is what you have as a line. Next you wanted to plot the parabola which is y square is equal to 2x. Now you see you have y square here, so that means if you substitute the positive values of y, it would give you the same values of x, and if you substitute the negative values of y, that would also give you the same result. So that means this is symmetrical about x axis. So this is symmetrical about x axis. If this is symmetrical about x axis, so that means we would have a which parabola? Right hand parabola, right? And what are the point? We also knew this parabola would cut or meet this line at 2 points. One is this 0 0 and the other point is 1 by 2 comma 1. So this point, right? So this parabola would meet at this point. So what other points will it cut the parabola at? So when x is equal to 1, the value of y would be square root 2, 1.414, right? So you could draw the parabola like this. Here it would go something like this, somewhere like this. It would be more curvier, right? Something like this. And similarly on the opposite side it would be something like this, right? Something of this kind. So here let's call this point as O, this point as A, and the coordinates for this point, they are 1 by 2 comma 1, which is the point of intersection. So here in this question we are to calculate the arc length passing from the point A to the point O. So we are interested to calculate what is the length of this A, right? If I draw it enlarged, so we would have something like this, right? And the line is going something like this. This point is your point A, which is 1 by 2 comma 1, and this point is your origin, which is 0 comma 0, right? And you are interested to calculate this this much portion of the length, and you basically have to determine what integral would give you this particular value. So this is what is required, right? So if you remember, to calculate the arc length, what do? We perform the integration. And what kind of integration do we do here? We just integrate very small portion of s, where what is s? Where s is the arc length. It represents arc length, right? So basically what we are doing, we are just taking very small portion of this arc length, right? Which we are calling by ds, and then we would integrate it from this limit to this limit, from the limit here to the limit here, so that we would get a final complete arc length between the point 0, between the points O and A, right? So we are interested to calculate this integration of ds. So we wanted to calculate this thing. So how we can do that? Now for that, you see, if you take this very small portion ds from here, and now you wanted to see, this is some curvier portion. If you take very small portion, it would act as some straight line. So you could draw a line like this, and you could draw a line like this. So you see you have a 90-degree angles over here, right? If you have a 90-degree angle over here, so you could apply, if I say this much small portion is my dx and this much small portion is my dy, then what would be ds according to Pythagoras theorem? It would be ds square, that is equal to dx square plus dy square. Hypotenuse square is equal to base square plus perpendicular square, right? So from here I could evaluate ds in two ways. So the first way is that I could write ds square, that is equal to dx square, and I could write this to be 1 plus dy upon dx whole square, right? Or you have ds is equal to dx square root of 1 plus dy upon dx whole square. This is one thing. this is one way of representing ds in terms of dx. Now second thing, I could represent the same ds like this also. In place of taking dx square as common, now we can take dy square as common. So you would be left with dx upon dy whole square plus 1 here. So that you have ds as, so this ds is dy times the square root of 1 plus dx upon dy whole square. So you have these two ways of representing this. Why I am taking both the ways? Because this is a multiple select question and you have to suggest the correct integral in order to get the correct answer, and not the final value, not the solution of the integral. So you see in the first case, you could write s as the integral, right? In place of ds we are using this first way, we are writing this thing. So it is 1 plus dy upon dx whole square root, and the integral is now performed with respect to x. So that means we have to now write the limits for x. So in the figure here you see the x here that varies from the point 0 to the point 1 by 2, right? So here the limits are 0 to 1 by 2, right? So we just have to solve this one. And in the second case, let me write down that first. In the second case we'll be solving that in a few moments. You have s as the integration of ds. So in this case we are writing the second value for ds, that is this one. So that is 1 plus the square root of 1 plus dx upon dy whole square, and the integral is being performed with respect to y, right? And what are the limits for y? You see the y here, complete y here varies from the point 0 to the point 1. So the limits for y, they vary from 0 to 1. So you have y varying from 0 to 1. So in order to solve this thing here, what we are to do, we are required to calculate dx upon dy, and we are required to calculate this dy upon dx. And because we are to calculate the arc length of the given parabola, so in this case we know the equation for parabola, that is given to be 2y is equal to y square is equal to 2x, right? So that now we want dy upon dx, so we will differentiate it. Differentiating it, we obtain 2y dy, that is equal to 2dx, completely differentiating it. Now we want dy upon dx. So from here you have dy upon dx, that is equal to 2 and 2 cancel out. So dy upon dx is 1 upon y. So you see, when you substitute the value here, you are required to solve this integral in terms of x. So that means you have to convert this value of y in terms of x. So what is the value of y? It is from here, from this equation, it is square root of 2x, right? So you have dy upon dx is equal to 1 by square root 2x. So now substituting this value here, your s become integration x varying from 0 to 1 by 2, 1 plus 1 by square root 2x whole square root, right, and dx. We just have to solve this one, not solve but simplify. So it is square root 2x, how much is that? It is 2x plus 1 divided by 2x and complete square root dx. So this is what we obtain in the first case. So let's have a look at our options here. So in the options you see this is the option number C here. So that means option C is the correct option when we take the first case. Now when you solve this second case here, if you see and remember your parabola, given parabola, that is y square is equal to 2x. Now again we differentiate it so that we obtain 2y dy, that is equal to 2 times of dx. From here now we want the value of dx upon dy, so it would be this 2 and 2 cancel out with each other. So dx upon dy, in this case we are shifting this thing to this side, right? so it is equal to y only. And here, because we are integrating with respect to y, so we'll keep it in terms of y only, right? So let's substitute it here. So when you solve this one, you have s is equal to integration y varying from 0 to 1 of 1 plus, in place of dx dy, now we'll be substituting y. So it is y square square root dy. So this is the integral that you obtain in this second case. So in the second case, you see we have option A as the correct option here. So here in this case, let me write down. So option A and option C are the correct options. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.